Okay, so I just run 4 different vectors here. And the first one is a character. And the second one, even though you have 1, 2, 3, but you have true here. And it turns out this is numeric. And the third example is logical, and you have character with logical. So this is character. And the tricky one is 1, 2, 3, and another 4 in the quotation mark. So this is treated as a string. And it's become characters. So what can we conclude here? Why? So for example, if you have like 1, 2, 3, and true, so what expected is like it can display numeric and logical. But in this case, you see only the class of that vector is only numeric. Right? So in the vector, you can have only one type. For example, logical or numeric or character. So if you have like mixing values, so I will force to design all of the values into one type of values. Right? So if you have, for example here, if you have like characters and number, and it will become like character. So in this case, I will have kind of like prefer character more than numeric. Okay. So it's kind of like according to the hierarchy, sometimes. So in this case, like character will be prefer. And the second example, like even you have number and also logical, but turn out the class of this one will be numeric. Okay? Yeah, so that's, I think, the last example of the vector, like introduction to the vector. And the second part, we are going to, let me clear this one first. How you can do subsetting vector. So for example, you have like different values in one vector and you want to get only one value from that vector. How can you do that? So let's use maybe the other vector that we already created here. Let's see. Yeah, so let's use this animals vector that we already created previously. So we have 4 different values here: mouse, cat, rat, and dog. So there's a way that you can get only one values in the vector by using square bracket. So for example, number 2, you will get cat. Okay. And what if you want to get 2 different values? So in this case, you have to use C. And then, for example, if you want to get 2 and 3, okay, so you get cat and rat. So the second task, and also a very common one, is like how to search for the certain strings in the vector. So for example, you want to use the same vector animals here, and you want to search for the animal which is a rat or the animal which is a cat in that vector. So you can use animals. So this is a vector that you want to use. And now you put animals double equal. So this is we'll use for the string. And you want to search for cat. So the double equal sign here is a test for numerical equality between the left and right hand sides. Okay. And see. Sometimes you want to see return, like you want to search not only cat, but you also want to search like red in the vector. So in this case, can I put like this? It's not working. So you have to put another animals here. And now it works, right? That's the first way. And the second way is that we can use to search for like specific string in the vector by using kind of like new function called this one. So this function allows you to test if any of elements of the search vector are found. So for example, you can use, in this case, you can use animals and which animals in the vector. So for example, I have this vector. And for example, dog. And another one maybe dog and goat. So in animals vector, we have, see here, we have 4 different types, right? Mouse, cat, rat, and dog. And in this case, we have rat, dog, and goat. So basically, this function will search for if any animals or if any elements in this vector is also in another vector. So try to run it. So the first one is false. False, true, true. Wait. Okay, so Kevin, I don't know why it becomes true here, but basically they are compared in the order, right? So if you have like rat, dog, and goat, and then you compare mouse to rat, so it's false.
So,
right?
So I was playing with that a little bit. It applies like from
the other direction?
Yeah, it applies this way. So it's looking at, so if you try, I'll drop this in the Etherpad, down at 194. So if you try to run that command, the cat and animals.
Yeah, it should work, right?
And so cat and animals, if you run that, you see it checks the list of animals against cat and says, yes, cat is animals. So you want to run, like if you want to check.
Are you like cat or like dog?
Hmm?
Are you
So in this case, it's like you are searching cat in the animals vector,
It's,
and
yes.
then it will
yes.
become true because in animals vector you have cat.
But if you run it the other way, it
So it's-
like so you run
Let's see.
animals and cat. So if you run animals and cat, it'll run through each element in animals and tell you, is the first one cat? No. Is the second one cat? No. Is the third one cat? No. Is the fourth one cat? Yes.
Mm-hmm.
Is the sixth one? Well, I have more because I added a possum and some other ones as well. So yeah, if you run animals and cat, it will run through.
Okay, yeah, I got it.
So I think it's so I think it basically is like a macro that does what you did on line 122 there,
Mm-hmm.
where it just sort of expands out into that.
Yeah, that's why we get this value. Okay. So I think maybe the better way is this way, like Kevin mentioned.
And so it depends on what you want to do.
Yeah.
Because like being able to get that that Boolean vector allows you to do like what you have if you scroll down on your scratch pad up top. This I think you still have it.
This is the
Out
last
there
one.
on line 132.
Yeah.
It allows you to do that, which a lot of stuff in R uses that kind of idea where you subset
Yeah.
based on like applying, which I don't think we're gonna do that today, but you like apply one of these Boolean matrices to your data set and only pull out like lines where the values are true.
So I usually use this way because, so for example, you have like the vector and then you want to pull out all the elements in the vector and then display that. So that's maybe like easier way and maybe clear like you want to see which like string you want to search in that vector, and then you kind of like execute it and then display it, right? Okay.
So you're comparing every variable with cat. Once you add.
You mean like in this case, or
No,
let's
yeah,
go
when
back.
you have animals percentage in percentage. So you then when you add animal percentage in percentage cat, that means you're comparing cat, rat, cat, dog.
So yeah, so for example, in animals you have 4 different elements, right?
Mm-hmm.
For example, like rat, dog, cat. So they will compare rat and cat, dog and cat. So it's like false, and true.
Right, right.
Okay, I think so. The last part for the introduction to R that we are going to cover the missing data. Okay. Are we good now? Okay. So for example, like you will see like a lot of case in the morning session, we have a lot of like NA value or maybe like not a number value. So for example, I have another vector which is like, for example, 2, 4, 6, and 1 NA value. So this is example of the new objects that we have. So in this case, in the vector, you have missing value. So sometimes for the like statistical analysis, you want to figure out what is the mean value, what is the median values of that. So for example, if you want to calculate the mean value of this height, let me see. What happened? It's NA, right? Because there's a NA value in your vector. So what can we do? Like just remove all the NA? So I can do this way. And then we use NA dash remove equal to true. And it's 4.5. Again, for example, you can calculate the maximum of this one. So the maximum. And then without the NA remove, it's another NA. Now you can apply remove the NA value. It's equal to true. Sorry. True.
And
It's
so,
six.
I dropped the help command for that in operator. It's help match that talks about in great detail all of the pattern matching. And so,
Oh, yeah.
sorry for interrupting.
No, it's okay. Thank you. Okay, so now there's another way. For example, you want to extract only the values which is not the NA. So you can do, for example, height. And this is vector, right? So you want to extract the vector, so use the square bracket, right? So if you use like is dash NA and apply to that vector, is dash NA means extract all of the NA values from this vector. And if you want to extract only the vector or only the elements which is not missing value, so you can use this one. Let me see. Can you see? So this means extract only the elements or only the values which is not NA in the vector. And you have to put the vector here, right? So this square bracket is like extracting the value in the vector. And now run it. So this is 2, 4, 6, and 6. And what if you use this one? Of course it's NA, right? The another way that you can use is NA dash omit. And apply into the vector. So how does this look? So NA omit is different from this function. It's dash NA because it will return the objects is another atomic vector. And also you get more information about like attributes, NA action. So you can choose either way which is applied to your data set. So that's the second way. And the third way that you can use to remove the vector using complete dash cases, and then put the vector here, right? So this is like the same with the is dash NA. So I just show you guys 3 different ways that you can use to remove the missing values. Okay, so to conclude this part, we are going to do a very short exercise. I'm going to put another vector So I'm going to put another vector here. Okay. So what we are going to do is using this vector, and then the first one is create a new vector with the NAs removed. And the second one is use a function, I guess it's median, to calculate the median of the vector. So it's similar to the mean and max function. And this is the second one. And the third one is use R to figure out how many people in the set are taller than maybe 76. So the unit is inches. Okay? So to remove the NA value, you can use, oh, you don't have it here. Yeah.
Is this right?
No, you can use this. So there are 3 different ways, but you can use this one. And now you subtract.
Yeah.
should we go through the answer? So I have this vector, right? And the first thing I want to do is remove all the missing values. And she has the trouble if I just use this one. And if you want to remove the missing value, right? So you use NA.
Oh, that's why.
No, not this. Sorry. So, and now you are applying to the vector, right? So this is how you run it, right? You run it. And so now she wants to apply median into that vector, right?
Now I know. So I need to have that command in order to clean the missing data and then,
So this is to calculate the median of this vector, and you have to remove all of the NA value. The second way you can remove all of the NA value is using NA-omit. Okay, so the third part is what is the length or how many high value which is greater than 67? Anyone got that number? No? 6? Okay, let me see. I don't know the answer yet. So someone using this. So you can apply 67. Does this work? No. No. Why is that? Because you already removed the NA. But why it didn't apply here? So look at this vector. This is the original vector. This is not this vector. So you are going to create a new vector here. No NA. Maybe like this. So you are going to create a new vector, right? So now you have to run this with the new vector. So let's see, no NA. Sorry, my mistake. There's no S here. Does this work? Because now you have to apply the selection to the new vector. This does not include any NA value. So if you use the highest vector, that's going to apply to the original vector. Okay. So how you can count this? How many values which is greater than 67? So basically, this is very simple vector, so you can count, right? There are 6 here, but if you have like very big or very large vector, so I'm gonna create another vector here. Okay, above. So you are going to create another vector here, and you subtract only the values which is greater than 67. And you have new vector here, and now you can check length. 6, right? So this is like basically just apply what we have done.
No, but we just combine lines 60, 162 and 63, so we don't need additional line.
That's very smart. We are going to talk about it tomorrow. Yeah. But that's really good point. So whenever you have to create new variables or new objects, you are going to like end up with like tons of different objects. So we have like very smart way to deal with that using the tidyverse package. So I'm going to talk about it maybe tomorrow. Okay, are we good so far? So I think maybe we're gonna have like very short break, 10 or 15 minutes, and then maybe 10 minutes, right?
10 or 15, yeah.
Yeah, and we have like, I think this part is gonna take, maybe we are gonna have like 10 minutes break, and then we go back with starting with the data. So we are going to work with data frame and subsetting data frame and formatting the dates. Okay, sounds good. Join CSV. So this is downloading the file. Okay. So whenever you finish one of the command, so in the console it will display this greater sign. So if you see that one, that means the command runs successfully. But sometimes, for example, I just show you here, if you didn't put this parenthesis and then you run it, so it has a plus sign. So that means you haven't finished the command. So just put escape and then run the command again. So now I have to put the parentheses here. I'm not gonna run it again because I already downloaded. Yeah. So did you all get the file in the data folder, right? So, okay. So I'm gonna show you guys how you can read that file. So basically, this is like a comma separated value file, CSV file. So we are going to use another function called read.csv. Okay, and I think I have it in the data folder, right? Tab completion, and then, so here the tab completion is very useful because this is very long name. So you don't want to spend like the whole time to type exactly the name of the file. So you can just put the tab, and then it will completely the name of the file for you. Just put the tab. Yeah, T-A-B on the keyboard, right? Tab, and then it will automatically complete it.
What was that again?
Hit tab.
I thought I mentioned it. Just hit the tab on the keyboard.
Like when you typed in a couple letters.
Yeah, just type maybe few, first few letters. But sometimes if you have a lot of files with the same name, so then you are going to try like a little bit more, maybe few more letters, and then type completion. They will maybe complete the long name for you. So,
Oh, wow.
so that's the way I did with the directory as well. So for example, here I have data, right? So you can put tab, and it shows you the directory, right?
I run it, it came out of the directory, yeah.
So now you want to create the new objects with this file. So you can put survey, option minus, okay? So we have new objects called surveys. And then you can run it. So how you can display the new file? Just surveys. Tab completion. There's a lot of stuff here. So sometimes it's not really good way to just display, yeah. It's like, I think 34,000 something
Yeah.
rows.
It's a lot.
So the other way you can do is just check first few lines using head function. So head will display first 6 lines of that data frame. So you put survey here. So this is how it looks. So basically this data frame, they have, this is like different columns: ID, month, day, year, plot ID, species, sex, height, foot length, weight, and genus, species. And first 6 line or first 6 rows in the data frames. So this is another like very quick way to check whether you load the file correctly or whether you have the right files. So another way you can use, so normally if you use this function, views, and you put the data frame, so they will show up here. So basically, it will not mess up with your script or control. So this is also another easy way to see like your data file completely. So you can use views and then surveys. Okay. So in this case, we call this is a data frame. So what you recognize in the data frame is like, it's basically the format of the table, right? Where you have the columns are the vectors. So each column are one vector. And in each vector, you have different values of that vector. But for example, you have a month, day, and year, which is like numerical values. And some other columns, you have like species ID or genus and species, which are characters. So it can be like combine multiple or different vectors. But in each vector, you should have only one type of the values. It can be like character, or it can be like numerical, or maybe logical, right? So that's basically the data frame.
Yeah, no, this first one wasn't working, my surveys. I don't know why. I mean, after here it worked, all the list came out. But then when I hit this one,
So another way to check the structure of the data frame, that you can use str, which is structure of surveys. And let's see how it works. So let's check it here. So this data frame has 34,786 observations and has 13 variables or objects. And then they will classify what is this vector type, like integer, or So in this case, this is factor. And I'm gonna explain about it a little bit later. Why it shows as a factor, not maybe characters. Okay. So there are some other ways that you can do to inspect your data frame. So you can use like dimension, DIM, dimension of survey. And this show you like how many rows and how many columns. So the first one is a rows number, and the second one is column number. Very briefly checking the data frame. Or I can use end row. So end row is to check how many rows you have in the data frame. So it's returned exactly the same number, right? And the same one you can use like how many column, n column, 13. Okay, so far we have head surveys. Another way is view surveys, structure of surveys, dimension of surveys, how many rows and how many columns. So in addition to head, you can use tail. Very funny, right? So it will print out like the last 6 rows of the data frame. So in opposite to head is the tail. The other way is that you can check the names of the columns. You can use names and surveys. So this is the name of the columns in the data frames. Record ID, species ID, month, day, year, genus, weight or high foot length. So that's the basic how you can inspect the data frame. So we're gonna do very short exercise. I'm gonna put it there. So let's see. So in line 214, based on the output of the structural surveys, can you answer the following questions? So what is the class of the object surveys? And how many rows and how many columns? How many species? So you're going to apply the structural str function and then see how it looks. Should be very quick. We already did it.
We did that.
Yeah. So in this case, you can see here, the class is data frame, right? How many rows, how many columns, and species, how many species you have. "48." So you have to check species ID,
48.
right? 48 levels. So there are 48 different species here. Okay, so that's very quick about data frame and inspecting data frame. Let's move to the next part is indexing and subsetting the data frame. So basically it's similar to how you can extract the value from the vector. So in this case, how you can extract the value from data frame. So the difference between vector and data frame is in the vector you have one list of the values, right? But in data frame you have both columns and rows. So that's basically the difference, and the way that you can extract the value is almost similar. So let's say, so for example, I want to extract the survey data frame and using the square bracket, right? So you want to extract the first element in the first column of the data frame. So the first number is always the row, and the second one is column.
Yeah.
So the first element or the first observation in the first column, and separated by comma. So it will return this one. Let's check the other one which has like more meaningful value. So you can say maybe the first element in the sixth column, right? So it's something like NL, and I think it's belongs to the species ID. Yeah. So the number 6 column is species ID.
Yep.
You can see it here, actually.
So, it gives a list there because it's not a numeric. Like, why does that one have the list of levels underneath it?
I will show you a little bit later
Okay.
why it happens like that.
Okay.
So you can check again, the first element in the 6th column is NL. So that's what you did, right?
Yeah.
This is NL. So the other ways that you can check. So for example, if you want to extract the first column, and let me do the other thing as well.
Brackets. The first one is the row or the column.
The first one is a row, and the second one is column. So these two are a little bit different, right? Because you see the comma here. So in this case, if you use only number 1 and without any comma, so they will return the first column as a data frame. But if you use like comma 1, it will return as a vector. So let's see. So this is very long one. And this one. So this is a vector.
So leaving a space on the row and then just putting one in the column, what are we looking for in there?
So in this case, we want to extract the first column.
Right, and then the other one?
And the other one is the same, but the difference is in the first case, we want to get the output is the data frame. And the second way is the output is a vector.
Okay.
Sounds good? So another example is, let's see, if you want to extract the third row of the data frame. So it's pretty simple, right? third row. And yeah, this is the third row.
Yeah.
And it will return here. So what if you want to extract the first 6 rows of the data frame? So it's kind of like equivalent to head function. So
yeah.
yeah, so one way is like head surface, but the other way, using this.
There will be like 6 of them, right? 6 of
1
them.
to 6.
Yeah.
1.
Oh.
Okay.
Column 6, okay.
And this is first row, first 6 rows. So this is equal to head surface. So what if we used, do you think what's the difference when we use this? And maybe try this.
Yeah, because that's the 6th row and the first column. Where's
But it's gonna change the order, increasing or decreasing. So what if we want to, another way to use, to extract the first 6 rows, let me show you. So if you want to extract like whole data frame except the first column, it doesn't apply here. So row and now column. -1.
That is for what again?
So you want to extract the whole data frame except the first
Except
column.
okay.
So you use
Subtract
minus.
it, okay.
So now you can apply this into, if you want to extract only first 6 rows.
Oh, only the 6 rows?
How can we use it?
We would have to eliminate it.
Of course, it's not like simple as a head surveys, right? But this is like different way to look at this. And of course, I will prefer head surveys. But this is the same way to apply minus. Sometimes you don't want to get, so you have data frame and you just want to get the data frame without that column. So you can use this way, minus something. Minus first column, minus second column. And column. So this is the same as head surveys. Okay, so that's how you can kind of like extract the different column or different rows in the data frame. And the another way is like how you can extract the columns and rows, maybe the column names, by using the names, not the number. So basically it's very simple, like you can just put the name of the columns. So for example, surveys, and you want to extract maybe species ID, right? That's what. So this is species ID. So as I mentioned before, if you use like comma, it will be like vector. So if you want to return as the data frame, so you can put like this. So this is another data frame. So it looks maybe better, right? Another way which is like very powerful as well, that is dollar signs. So if you click on like using the data frame and use the dollar signs, so it will show up here which column you want to use in that data frame. So it will result another vector. So I personally think this is really helpful way to do it. So you can extract any columns in that data frame using dollar sign. And also this one we will apply a lot in the next step. Okay, so now let's do the exercise a little bit. Another exercise. This one is pretty long, so maybe you can spend 10 minutes. So firstly, you create a new data frame. You can call it surveys 200 that contain only the data in row 200. And now second one is using enrolled to get the number of the rows in the data frame. And the purpose of this case is like you want to use the enrolled to the further step that can apply. For example, you create a new data frame from the last row. How you can use the end row value to apply to the last row. And number 3 is use the end row to extract the row that is in the middle of the data frame. Okay, I think we gonna move a little bit quicker because it's almost 4:27. So I'm gonna create a new object called number of rows by using just enroll functions. So you can call like survey the last row and create these objects using surveys and then extract enrolled. Right? Because enrolled is also the last row, last row. And survey misto is something like this. So you can use the same data frame and divide by 2. Does it make sense? And if you want to extract the first 6, maybe using head. So it's equivalent to the head surveys. But this one is another way. -7 to enroll. Right? So this one is to extract the last row, and this one is to extract the middle row of the data frame. And number 4 is to extract only first 6 rows in the data frame. So the purpose is just using enroll function. And then you're going to create another new objects called enrows. Okay, let's move to another one called factors. So let's go back to the structure of survey that we have done before. So as you see previously, we have this data frame has 13 different variables, right? And then you see like a lot of factors here, like species ID, sex, genus, and another species plot type. So factor means the categorical data. Okay, so they can store as like order or unorder. But basically, it looks like the character, right? Because when you see, for example, genus or species, it looks like character vectors, but they actually treated as integer vectors by R. So that's why we need to be careful when we treat with the strings or characters in R. So let's say another example of the factors here. So I'm going to show you again how we read the file with CSV, right? And I'm going to read this file. So this is the way that we did before. So in this ways, I will treat all of the other like species ID, sex as a factor. So sometimes we don't want to do that because we want to keep the categorical variables as it is. We just want to, maybe sometimes just want to treat only one or two different variables as a factor. And tomorrow you're gonna see like when we need to convert these kind of like variables into the factor. So it's much more easier to use with ggplot2. But in this case, we want to keep your original data frame as it is. So we used another one here. We call string as factor equal to false. This is equal. So in most of the case, if you don't put this one, it will be like default as true. So when you read the data frame, everything will be like all of the characters and integers will be converted into factors. But we don't want to do that. So we want to keep as false. Yeah, we have to finish in 30 minutes. So we can run it again. And now you can check the structure of surveys again to see how it looks.
Please complete any work you are doing on a computer. Thank you for your
String as factor as false, and survey 2, and in this case I said it's true. So let's see what is the difference. Did I do something?
So does it read CSV?
It looks fine.
Yeah, previously it works fine.
Maybe put the data.
Strings as factors.
Yeah.
So you have string as factors? So right here.
Oh,
Strings.
okay. Yeah,
Oh, here is a mistake.
yeah.
Oh yeah, but I had a strings also.
Yeah, it works now.
Yeah, yeah.
Figure it out. So this is the structure. So now you can see,
And that's why in industry people do a lot of pair programming.
yeah,
because-
that's why.
Yeah. It's easy to notice someone else's typos.
Okay, so survey 2, I said is true.
Oh, yes, you worked out, right?
And now you can see the difference. Can you see the difference here in the genus species? So when you set string as factor is true, so everything like the character will be converted into factors.
And what factors do is kind of compress the data so that there's like, there becomes a list where like 1 equals Ammodremus and 2 equals Ammospermophilus. And then in the data table, you can kind of see in there, it actually becomes a numerical list of 1, 2, 3, 4, 5. So that's a data compression technique, and 2, you can do some neat techniques on factors that we will get to tomorrow.
Yeah, that's true. That's what I mentioned in, we have to encounter it in ggplot as well. Okay, so okay, so let's see. We have some remain parsed, including, let's see, because I just explained very briefly about factors, and actually I want to explain a little bit more about factors and also how to convert the factors and how to rename the factors. So maybe we can cover it maybe tomorrow morning, maybe around 20 or 30 minutes. And then after that, we will jump into manipulating data frame and ggplot too. Sounds good? Yeah.
Thank you guys all for coming today. Sorry I wasn't able to introduce myself before. My name is Bonnie Fong. I'm the one who's been coordinating these workshops. And I appreciate you're all coming. These are sponsored by the Cancer Seed Grant, and this wraps up the second year of our funding. So this is the final data skills bootcamp that we're having. If you haven't done so already, make sure you complete one of these model release forms because we have been recording our session. There were a lot of students on a wait list who weren't able to get into this workshop bootcamp, and so we want to make the recording available. I'll see you all tomorrow. Anyway, I'll wait.
Yeah, and another announcement, like if we will be like very appreciate if you can write down something. So in the sticky note, like what we should improve tomorrow. So you can write down something like what we need to improve in the red sticky note and what is okay today. So we can maybe try to improve a little bit tomorrow. So we can like go over a little bit more. Or maybe you think like it's too fast or too slow or something like that. Thank you.